compareTo is a method that you might choose to write if you're implementing a class and you want objects of your class to be able to, you want to be able to compare objects of your class. So you want less than, greater than, or something that resembles equals for your objects. Right? So it's the analog of less than, greater than, and equals to. Right? And so many value type objects have what are called a natural ordering. Right? So that is for any two objects x and y, x less than y is meaningful. Right? So in other words, if you want to put your objects in order for some reason, so for example you want to sort a collection of objects, then you want them to be comparable. So for example, all the numeric types are comparable, right? So the number 0 is less than the number 1, for example. For strings, you can compare strings by their dictionary order, right? So ant comes before zebra, for example, right? And dates you can compare by chronological order. So January 1st, 2022 comes before December 1st, 2022. Right? And if you're talking about the classes that I've been using in the lecture slides, if you have 2 points, you might compare 2 points by how far they are from the origin. Right? There's lots of ways you can compare 2 points. One of the ways you might do it is by their distance from the origin. Right? So if your class has a natural ordering, and if you think that people might want to sort collections of objects of your type, then you should consider implementing what's called the comparable interface. Right? If you do this, so if you do in fact implement the comparable interface, then that lets people who use your class sort arrays or collections of your object. It also lets people use things like tree set and tree map, right? Because the tree set and tree map are both sorted collections, right? Sorted set and a sorted map. Okay, so this is the first time I've actually talked about an interface. So I'm saying here you should implement this thing called the comparable interface. So at this point, you need to know what an interface is. Right? You've actually used them before. So if you've ever used just plain old list or plain old set or plain old map, then you've actually used an interface in Java already. Right? So an interface is usually just a group of related methods with no body. Right? So they have no interface. It's just a bunch of methods. So for example, this thing called comparable, it turns out it's a generic interface, which is why you see this funny less than t greater than thing here. Right? But notice that its type here, right? It's not a class, but it's this thing called an interface. So we'll be creating our own interfaces maybe in a couple of weeks. Today we're going to learn how to implement an existing interface. Right? So comparable is an interface that's defined in the package java.util. And so this interface here, it says there's this method here. Right? So it says there's this method that returns an int. Right? Its name is compareTo, and it takes in an object of type t. Now notice that big T matches that t that's here. Right? So if I have a comparable integer, for example, then that lets me compare two integer objects. Right? So that whatever type is here, when you create the generic type, right, you just substitute it for the type that's there. Right? So if we had comparable string, then that t there is also string. Right? So a class that implements an interface promises to provide an implementation for every method that's in the interface. Right? So any class that says it implements this comparable interface is saying it has this method called compareTo. Right? In an interface, all the methods are public by default. Right? So because there's no access modifier here, right, then in an interface you read that as being public. Okay, so what does this compareTo method do? Right? So compareTo, if you look at its documentation, says it compares this object with the specified object for order. Right? So in other words, to use this method, you would write something like the following. Okay, so I know, for example, string implements the comparable interface. So I can make a string s, and we'll do, I guess, ant. Right, and then I can make a second string t, and I guess we'll do zebra here. Right, and now I can write something like int c s compared to t. So inside the compareTo method, right, remember S is going to be this, right? And T is going to be, if you just read the documentation, it's the specified object. Which is, I think I always call it other as a parameter name. Right, so you're allowed to write something like that now. All right, so compareTo says it returns a negative integer if this object is less than the other object. Right? It returns 0 if this object is equal to the other object, and it returns a positive integer if this object is greater than the other object. So in the example on the board, right, ant comes before zebra, so ant is less than zebra. So C here will be a negative integer. Right? If you wrote T compared to S, then zebra comes after ant. So zebra is greater than ant, so you'd get a positive integer here. If you wrote S compared to S, you would get 0 because ant is equal to ant. Right? So it gives you less than, greater than, and equal to all in one single method. But it's up to you how to interpret the return value. Okay, so it's possible to write something like this. So using the same variables here, I can create something else. So I can make a point, P, right? And then you are also now allowed to write C equals S compared to P. Right? Which doesn't make any sense, because I'm now trying to compare a point to a string, and so that should throw an exception, and in fact it does. It will throw a class cast exception in this case. Okay. Now, suppose we want to implement, suppose we have our point2 class and we say, hey, I want to compare points by their distance from the origin. What do I do? Right? So, and so you say, well, okay, I want to provide this compareTo method, right? So to implement compareTo, the version of the method that you would write looks as follows, right? You would write public int compareTo and then point2, right? Because I want to compare a point to another point. Right? To implement the method, it's pretty straightforward, right? I want to test the distance of this point to the origin, right? And I want to evaluate the distance of the other point from the origin. Right? So I've got 2 points, right? There's always this point and the other point. Right? And then I'm going to compare those 2 distances. Right? So if the distance from this point to the origin is less than the other point's distance, right, I'm going to return a negative integer. If the distance from this point to the origin is greater than the other point's distance from the origin, I'm going to return a positive integer. Right? And if they're equidistant, so they have the same distance from the origin, you're going to return 0. Right? Okay, so if you decide that you want to implement compareTo, right, then what you should do is you should tell everybody you're going to implement compareTo. The way you do that in Java is, right, after your class name, you tell other classes that point2 implements the comparable interface. Right? So you write implements comparable and then point2 inside the less than and greater than sign. Right? So as soon as as soon as the compiler sees that, right? As soon as you write that in, the compiler will look at your class and it's going to look for the compareTo method. Right? If it's missing, it's going to tell you, hey, you said you say you're implementing the comparable interface, but you don't have this public int compareTo method. Right? So number one, the compiler will tell you there's a problem. Once you put it into your class, right, the compiler is now able to recognize that your class in fact implements comparable. Right? So it also knows that any other class that requires something where you can compare 2 objects can now use your point2 class. Right? So for example, collections.sort is the thing that sorts a list of objects. It turns out that that method requires your class to implement the comparable interface, right? Because it needs to compare 2 objects to put them into order. Right? So as soon as you write implements comparable, the compiler now knows that there's going to be a compareTo method inside your class. Right? Now how do you implement it? Well, it's pretty straightforward. right? So you compute the distance. In this case, you compute the distance from the origin for this point. Right, so again, remember, sorry, I need an eraser. So the way you're going to use this method is as follows. Right, so you're going to have a point to object, we'll call it P, right, equals something, it doesn't matter what, as long as it's a valid point. Right, I'm going to have a second point to object Q, and that again equals something. Right, and now I can write something like P dot compare to Q. Right, where inside the method, P is this, right, and for this method, Q is other. Right, so you just compute the distance of this point to the origin, which is right here. Now remember, how do you compute the distance of a two-dimensional point from the origin? Well, it's x squared plus y squared, take the square root, right? There's a method in the math class that does that for you. It's called hypot, right? You should use hypot instead of computing x squared plus y squared, take the square root yourself. Because if you compute x squared plus y squared, it's possible for the powers and the sum to go out of range for your type, right? So for example, our x and y are doubles. So if you have a very large double value x and you square it, that can become positive infinity, right? It goes beyond the greatest value that double can represent, right? Similarly, if you square y and it's very large, that might go beyond the largest value that double can represent, so you'll get positive infinity, right? And then if you compute the sum of two large values, that can also go beyond the largest value that double can represent. Hypot is fancy, right? Hypot computes x squared plus y squared square root, and it's guaranteed never to go out of bounds. Right? Exactly how that works is way beyond the scope of this course, right? It's something you'd learn how to do in a numerical methods course. Right? So hypot is the preferred way of doing this rather than computing it yourself. To compute the other distance, you just use hypot again, right? Except this time you use other x and other y. Now remember, when you're implementing this method, right, you're inside the point2 class, right? So you can always write this x and this y because you have access to the fields x and y. You're also allowed to write other x and other y because other is a point2 object, right? So you're allowed to access its fields even though they're private because you're inside the point2 class. Right? Now that I have the two distances, I just compare them. Right? So this is actually the incorrect way to do it. Is this true? Hang on. Yes, this is slightly incorrect. Okay. So you can compare the two distances using greater than. Right? So if this distance is greater than the other distance, then I'm supposed to return a positive integer. Which positive integer do you return? It turns out it doesn't matter. Right? You're allowed to return any positive integer, so I'm going to return 1. Right? I'm now going to check, well, is this distance less than the other distance? Right? So again, I have to return a positive, in this case, a negative integer. Which one? It doesn't matter. Right? I'm going to return -1. Right? Otherwise, I'm going to return 0, which is a problem in this particular case. That's a very small problem, but it's technically a problem. Right? Now, why is this a problem? Right? It's because of the existence of minus 0.0 and positive 0.0. Right? So for doubles, so if I have two double values, so I have double A, and that's equal to minus 0.0, and I have double B, that's equal to positive 0.0, right? Then it is the case that I guess I want to do A, whoops, A equals B, right? So it turns out that's true. Right? So it turns out that's true. Which is a problem in this particular method here. Right? So actually, is that true? Can hypot ever, actually it's not a problem in this case. I don't think hypot can ever return -0. So it may not be a problem here, right? But if you're in the situation where you're comparing two double values, right, and you use less than, greater than, and equals equals, you run into this very small problem here where -0 is equal to +0, right? Now there's a problem because compareTo is supposed to impose what's called a total ordering, right? So what that means is these two things, so for double, for the class big D double, right, the value -0 is in fact less than the value +0, right? So if you do double, right, big D double, the object, right, D equals A in this case, and then you do big D double, I guess E, that's equal to B, right? When you ask is A compared to B, I guess I'll go over here. So when you ask the question, what do we have? D and E, right? D compared to. Right? Now remember, it's supposed to return 0 if they're equal, right? Now remember A, and so it was -0 and 0, if you use equals equals, they're equal, right? If you use compareTo though, you get back a negative int. Right? So the class big D double, when it compares the values -0 and 0, it thinks that -0 is less than +0, right? And that's all because of this, what's it called? It's the total ordering business, right? So in a total ordering, you're supposed to be able to place every object into order somehow, right? So if you have two different values, 0 and -0, right? Which, if you say they're always equal, then when you sort a list of doubles, you'll get back zeros and -0s in some sort of random order, right? Whereas if you actually sort them, if you actually have a list of doubles, big D double, and sort them, all the -0s will come before all the positive zeros, right? So the standard library imposes this total ordering on the doubles, right? So it says that -0 is less than 0, right? So instead of doing it this way, if you want to be consistent with the standard library, you should use the compare method in double, right? So to compare two double values, use compare. And compare will guarantee that when these two double values are compared, it'll be compared consistently. So it'll be compared in the exact same way that big D double does the comparison, right? So now your class will be consistent with the standard library if you do it this way. It's also a lot easier to write, right? I don't have to write two if statements and then a third, I guess possibly an else statement or a return statement here, right? I can just return whatever compare gives me back, right? Which is much easier to write, and you're also guaranteed that you're now consistent with the standard library, right? And you can do that for all the primitive types, right? So integer, there's an integer compare, there's a short compare, there's a long compare, there's a float compare, and so on and so forth, right? And so I would encourage you to use the compare method from the primitive types when you're, from the wrapper types when you're trying to compare two primitive values. Okay, so compareTo, if you look at the actual contract for it, so if you go into look at the comparable interface, right, you'll see, you can look up the documentation for the compareTo method. The documentation is, it looks similar to equals, right, in that it's very mathematical, the definition, right? The actual definition guarantees that compareTo defines what's called a natural ordering, right? So it makes sense that A is less than B, right? Okay. Oh, I guess we should look at an example where you don't want to do this, right? So one classic example where you don't want to implement compareTo is if you're implementing a class for rock, paper, scissors, right? Everybody knows rock, paper, scissors, right? Rock beats scissors, scissors beats paper. The problem is paper beats rock, right? So imagine you have a class that can have three values, right? One of the values is rock, one is paper, one is scissors, right? So you've got rock is greater than scissors, right? You also have scissors is greater than paper. And now you have paper is greater than rock. So that's an example of something that does not have a total ordering, right? Because paper beats rock, but scissors beats paper, and rock beats scissors, right? So if this had a total ordering, rock is greater than scissors, and scissors should also, which would also be greater than paper, right? So rock should beat paper, but that's not the case. So this doesn't have a total ordering, therefore you should not implement compareTo, right? Because if you do, people are going to be very confused, right? Because it's never going to work properly, right? If you had a collection of rock, papers, and scissors and tried to sort it, you'll get an inconsistent sorting depending on the initial ordering of the values in the list, right? So you have to make sure there is this thing called a total ordering, right? The easiest way for our purposes to define a total ordering is, does it make sense to sort these objects? All right, so when your compareTo is related to equals, right? Because it's the analog of greater than, less than, and equal to, right? Similarly, hash code's also related to equals, right? So all these three of these things are all related to equals. So remember what equals does, right? So equals looks at the fields of your objects and compares them for equality, right? compareTo is going to look at the fields of your object and do something with them and compare them less than, greater than, equal to, right? So there is this notion of what's called consistency with equals. So an implementation of compareTo is said to be consistent with equals when, right? So if x compared to y returns 0, right, then x equals y is also true, right? Which kind of makes sense given what I told you, right? Remember, compareTo is supposed to be the analog of less than, greater than, and equal to, right? So if x compared to y is 0, it kind of makes sense that x equals y should be true, right? Conversely, if x equals y is true, then it makes sense that x compared to y should return 0, right? So if you remember your math, right, this is if and only if, right? If you remember your math, right? So both of these conditions must be true, right? For us to say that compareTo is consistent with equals. Now the funny thing is, it's not required that compareTo be consistent with equals, right? So it's possible that you compare two objects using compareTo and you get back 0, right? But in fact, when you write x equals y, you get back false, right? Similarly, you can have a situation where x equals y is true, but x compared to y is not 0, right? And so you say, well, this is weird. This should never happen. But it turns out it's not that uncommon for this to happen, right? So imagine a deck of playing cards, right? So you have cards have a rank and a suit, right? So you can say that two cards are equal, right, if they have the same rank and the same suit, right? So the Queen of Hearts is equal to the Queen of Hearts, but the Queen of Hearts is not equal to the Queen of Diamonds, right? Because the suits are different, right? But in a lot of card games, you don't care about the suit, right? You only care about the rank, right? So in your class, you may have decided that when I compare two cards, I'm only going to look at their rank, right? So in other words, if I have the Queen of Diamonds and the Queen of Hearts, compareTo returns 0, right? Because they're both queens, right? Whereas equals returns false because their suits are different. So you can kind of see what's happening here. So if you think about what's going on inside of equals and inside of compareTo, right? If equals and compareTo use different fields to compute their values, then it can be the case that compareTo is not consistent with equals, right? So one more time. If equals and compareTo use different fields to compute their values, then it can easily be the case where you get different results when you use compareTo versus equals, right? And this is allowed, right? So it's easy to come up with a case for this, right? X compared to y. It's easy to compare this one. The second one's easy, right? It's playing cards. I think it's slightly harder to come up with a case for the first one, but it's possible to do, right? You just make up some class, and you pick the fields to compare, and you use different sets of fields in both cases. Right. All right, so when you implement compareTo, if you're comparing fields using float or double, use float compare or double compare to compare the fields. Right? That guarantees that your results are consistent with the standard library. Right? You have to be careful when you implement compareTo, because if your compareTo is broken somehow, then anything that relies on compareTo behaves unusually. Right? Now, unfortunately, tree set and tree map, right, two of the very common standard collections, they rely on compareTo. Right? So if you try to make a tree set or a tree map of something, right, then if you try to make a tree set or a tree map of something that doesn't implement comparable, right, the compiler will tell you very quickly you can't make a tree set or a tree map this way. Right? You can still make one, it's just that you have to tell it how to compare two objects of the type that you're trying to put into the set or map. Right? A lot of the methods in collections and arrays rely on a working compareTo, right? So sort, for example, relies on a working compareTo. Right? Okay, so the contract for compareTo says that it returns an integer, right? Negative, positive, or 0, but it doesn't say what the magnitude of the number should be, right? So occasionally, it's useful to encode some extra information in the magnitude. Right? Not always, but sometimes it is. So string, for example, does encode extra information in the value that's returned by compareTo. So a simple example is the counter class. Right? So if I want to compare two counters, the only thing that makes sense is to compare them by their value. Right? So the counter whose value is 5 is greater than the counter whose value is 1. Right? So that's the only thing that makes sense. Right? I can tell people what the difference is between the two counters, right, by returning the difference between the two values. Right? So in the counter class, I can implement comparable. Right? Now I'm going to implement comparable counter because I want to compare two counters. Right? So the signature is always public int compareTo counter. Right? Now in this case, I'm going to write the following. Right? I'm going to write this value minus other value. Right? So remember, this value is an int, other value is an int. In this case, right, this value is an int that's guaranteed to be greater than or equal to 0. Right? Similarly with other value. Right? So if I return the difference between these two values, right, that tells you the difference between the two counters. Right? So if I return 5, then I know that the value of this counter is 5 larger than the value of the other counter. Right? If I return minus 2, then I know the value of this counter is 2 less than the other counter. Right? That information might be useful to someone who's using the class. Right? You have to be very careful when you do this. Right? So why do you have to be very careful? So you might ask, oh, why don't I always implement it this way? Right? And the answer is because you have to be very careful when you do this. So I can do it safely here. Right? But in general, I can't, and you know why I can't. Right? The only reason you can do it safely here is because value is guaranteed to be greater than or equal to 0. Anybody see the problem? It's always the same problem. It's always the same problem when it's arithmetic. Anybody see it? It begins with an O. Anybody? O-V? O-V-R? O-V-E-R. O-V-E-R-F. It's overflow, right? So if value can be any int and other value can be any int, then that thing will overflow, right? So for example, if this value is integer min value, right, and other value is 1, right, then I take the smallest integer value and subtract 1, that overflows, right, and I end up with the largest integer value, right? You now have a compareTo method that returns a positive integer when this value is less than the other value, right? So you have to be extremely careful when you write something like that you don't overflow, right? In this case, it's fine because I know that value is always non-negative, right? So this is guaranteed never to overflow, right? If you use integer.compare, this will never overflow, right? If you use double.compare, it'll never give you back 0 when you compare minus 0 and 0, right? So you should always try to use the standard library methods instead of comparing things yourself. And when you try to be clever, always be careful that you're not introducing an error of some kind. Right? If that can overflow, this is a very hard bug to find. Right? The only way you'll find this bug is if you run a test where you happen to have a very large negative value there. Right? Or when you happen to have two values that do cause an overflow, right? Which is pretty uncommon for a lot of programmers' tests. Okay, sorry. Okay, any questions about compareTo? It's not hard to implement. You just have to be a little bit careful when you're computing the final value to return. Right. Okay, so the next lecture is on something called the enumerated types. I guess we should review quickly what we've done so far. So we've implemented our own classes now. Right, so you know that classes that are meant to create objects, right? They have non-static fields, right? The non-static fields, they represent the state of the individual objects, right? Every object has its own copy of the non-static fields, right? You know that you have constructors, and constructors initialize newly created objects, right? You know you have non-static methods, so non-static methods typically use the fields of the object to calculate some value, right? You know that toString should generate a string representation of your object. Right? So it's something that's human readable. Equals should test if two objects are equal, and the way you do it is by comparing the state of the two objects. Right? If you replace equals, you have to replace hash code. Right? And if you want to compare objects of your type, you should implement compareTo. Right? I guess you shouldn't forget about all the static methods that you can have in your class as well. Right? So remember that you can have static methods. The static methods typically only access the static fields of your class. Okay, so what are these enumerated types? So the enumerated types are meant for when you have some class, and the only objects of your class are constants, right? So there's a limited number of them, usually small, and every object is actually a constant. Right? So for example, the days of the week or the months of the year, right? The 4 suits in a standard deck of cards, the 13 ranks in a standard deck of cards, right? Possibly Canadian coins, provinces, and territories, possibly the planets of the solar system, right? And the arithmetic operations like addition, subtraction, and so on, right? All of these things arguably have something in common, right? And that is they represent a fixed set of constants, right? So 7 days of the week, right? 12 months of the year, 4 suits, 13 ranks, and so on, and so on, and so on, right? You'll notice that the Canadian coins is not a good example, right? Because not so long ago we had a penny, and we no longer have a penny in circulation, right? Well, in wide circulation, I guess, right? Similarly, there's talk of introducing a $5 coin. Right? So the coins may not be a good example, right? Canadian provinces and territories, again, may not be a good example, right? Because not so long ago, we created I guess it's the territory of Nunavut, right? Which never used to exist until not so long ago, right? So not necessarily constant, right? Planets of the solar system, we just kicked Pluto out not so long ago, right? It might come back again, so possibly not constant here either, right? Okay. So what used to be common when you had a bunch of constants is that you would use an integer value to represent those constants. Right? So for the days of the week, it would not be uncommon, right, to see something public static final int, right? So make a constant whose type is int and call it Sunday, right? And we'll say its value is 0, right? And then we'll do the same thing for Monday and we'll say its value is 1, and so on and so forth, right? And then if you are doing something like this, then you're probably working with dates, right? So you're probably going to have the months as well, right? So you do the same thing for January, its value 0, February is 1, March is 2, and so on and so forth, right? Kind of makes sense, right? This looks like it seems like not such a terrible way to do this, right? Now there's a problem though when you do this, right? The problem is you're saying the days are actually integers, right? And the months are actually integers, right? So while this is common, there's no type safety here, right? Any method that takes in an int parameter will accept a day or a month, right? Any method, right? So for example, I can take the square root of a day, which doesn't really make sense, right? There's no way for me to restrict a parameter to be only a day or a month, right? So there's no way I can write a method, right, that only accepts Sunday through Saturday, right? Because that's the same thing as accepting 0 through 6, which means it has to take in an int, which means I can pass any int to that method. Right? I can also do strange things like perform arithmetic with days and months, right? So I can compute Monday plus Sunday or January plus Tuesday, right? Which again doesn't really make sense, right? Now the last one sounds useful. I can compare days and months for equality, inequality, less than, greater. That actually makes sense, right? I want to know that Sunday comes before Tuesday, for example. That sounds like it could be useful. Okay, there's another problem with using ints, right? The value is an int, right? I have no good way to translate that value into a string, right? So if I use ints, right, I can't write a two-string method because the type is int, right? And I can't create a two-string for int because int's not even a reference type, right? So there's no way I can convert the int 0 to Sunday unless I make some funny method that takes in an int and translates it to a string, right? But that's definitely not two-string, right? Or it's not the standard two-string method. It's also not uncommon instead to use strings, which gets rid of the last problem, right? So for example, instead of using ints, I can use strings for Sunday, Monday, and Tuesday, right? And now I get rid of the problem of converting a string to a string, because it's a string already, right? But I still have a problem, right? Everything's still a string, so I can pass Sunday to any method that takes in a string, right? For example, I can pass it to, well, yeah, I can pass it to any method that takes in a string, right? The other problem is as soon as you do that, programmers start writing Sunday everywhere, right? Instead of writing the name of your class that's defining your constants, right? So instead of writing month.Sunday, everybody just uses the string literal Sunday. And now you have another problem where if you decide to change the definition of Sunday, everybody's code breaks because they just use the literal instead. Right. The other problem is that if you use strings, it actually takes a long time to test two strings if they're equal. Right? Because potentially you have to look at every character in the string, in the two strings that you're comparing, to determine whether or not they're equal. Right? So comparing strings for equality is a lot slower than using ints or plain old addresses. Right? So in version 5 of the language, Java got what's called an enumerated type, right? Or an enumeration. Right? So it turns out these things actually are all examples. They're all objects of type java.lang.big.enum, right? Which is also an object of type java.lang.bigoobject. Now the nice thing is that enumerations, they're proper classes, right? So you can have fields and methods and constructors, and they can implement interfaces and all sorts of other things, right? Which is nice. So they're super easy to create, right? So to make an enumeration of days, right, I just define public enum day. So enum is the keyword to say that you're creating an enumeration instead of a class. Well, it's still a class. It's a special type of class, right? But I now have a type called big D day, right? And the nice thing about this is that a day can only be one of these things here, right? So the day can only be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday, right? There is no day that's now equal. There's no day January, for example, right? Like we had the problem when we used ints. Right, and that's it. You now have a fully functioning enumerated type. Right? So I can create a day object, D, right? And I can set it to the day, Thursday, right? These are all just constants, right? So you just use them like, they're all public constants. So you just use it like you would any other public constant, right? You use the name of the class, right? And then the name of the object, right? So day dot Thursday is the day Thursday. Right? You can even print it out because the enumerations have their own built-in two-string. right? So if you print that out, you actually get Thursday in all caps, right? So enums, they provide a compiler-generated toString, and you can replace that version of toString if you want to, right? So if you wanted to print out, capital THU instead, you can do so, right? So you can just replace the implementation of Thursday, of toString, to produce your own customized string if you wanted to. So the way that enums work is that your enumeration class has exactly one object for every constant. Right? So back here, right? The language guarantees that there's exactly one object called day.Sunday. Right? There's exactly one object called day.Monday. There's exactly one object called day.Saturday. So in total, there's 7 objects in your day enumeration. Right? It guarantees that there's only one for each one of your constants, right? And it guarantees that they are, in fact, constant. Right? And so what does that mean? So if there's only one object for every constant, right, I don't have to use dot equals to compare them. I can just use equals equals or not equals if I want to. You can still use dot equals if you want to, right? But now when you're working with enumerations, you can just use equals equals or not equals, right? Why? Because equals equals tests do two objects have the same address, right? Enumerations guarantee that every constant, there's exactly one of those objects. So it always has the same memory address, right? So I can always use equals equals or not equals, right? There are no public constructors in an enumeration, right? So that guarantees that the user of your class or of your enumeration can never create a new constant, right? I guess this is I'll do this slide in the next one and then we'll call it quits. So enumerations, they are classes, which means they're types, right? Because they're types, that means I get all the benefits of compile time type safety, right? So I can have an enumeration called month, where I have the 12 months, right? And now the month type is distinct from the date type, right? So month.January is not equal to day.Friday or whatever, right? They're not even the same type. Right? So I can write a method that takes in a big M month, right? And the only values that that method will accept are the 12 values there, right? I can write a second method that takes in a big D date, and the only objects or the only arguments that the method will accept are those 7 objects there, right? So you get type safety as well, which is a big deal, right? Oh, I guess we'll stop there and pick this up on Wednesday. Any questions, I guess, for today's lecture? Boom. All right, see you Wednesday.